Hey everyone, Professor Lamar here, and welcome to our Chapter 8 video series. Before we get into Chapter 8, you might be wondering, where am I? This background looks a little bit different than what you've seen in previous videos, and if you've watched a few Zoom videos by now, you probably have seen people use virtual backgrounds on Zoom that allow them to appear to be in places that they might not actually be. So I've created a virtual background here, and at the end of this Chapter 8 video series, I'll reveal to you where I am. But for now, in video 1, I'm actually going to give you a pretty big hint so that you can start to make some educated guesses or hypotheses about where I am right now. Now, that hint is that. So some of us probably know now where I am, but if you don't, that's okay. It'll be revealed at the last video. Now, what we're going to do is go ahead and get started, and I'm going to share my screen and bring up our PowerPoint so that we can kind of talk about what this video series will look like. Now, in the Chapter 8 video series, Chapter 8 is all about basic experiments, and it first goes over like what basic experiments actually are and the key features in basic designs. So that will be video 1. Now, after this, Chapter 8 talks about 6 different types of basic experimental designs. And so this video series will be taking one video to talk about each type of design. That means video 2 is all about post-test only designs. Video 3 is all about pre-test post-tests. Video 4 is about the third design called Solomon foregroup. Video 5 is all about independent groups designs, which are also called between group designs. And this might be a bit of a flashback to stats if you've taken that. Video 6 is another flashback. Video 6 is all about repeated measure designs, which are also called within groups. And then video 7 is all about matched pairs designs. There are 7 videos in Chapter 8, and we'll try to keep these videos a little bit on the shorter side so that we can kind of progress through them at a good pace. But keep in mind that each video will basically tackle a different type of design, with the exception of this first video here, where we talk about a basic experiment. Now, I've also created a chapter overview to give you an idea of kind of on your own as you study, how should you organize the content in this chapter. And this first video here tackles the first part of this chapter. It's all about basic experiments and what they are. And before we get into this though, I want to kind of explain to you why I've taken those 6 types of designs and grouped them into 2 categories here. There's actually a lot of meaning behind that. I've taken the first 3 types of designs, post-test only, pre-test post-test, and Solomon foregroup, and I've grouped them together. And the reason why is because I want you to think of them all as belonging to the same category. When you design an experiment, you get to choose one thing from this category. In other words, when you design an experiment, do you want that experiment to be a post-test only design, a pre-test post-test, or a Solomon foregroup? Typically, you only get to choose one of these things though. So think of these 3 different types of designs as one category. And when you design an experiment, you get to choose one thing from category 2. The same kind of logic applies for point 3 here, or category 3. There's 3 different types of designs in this, and you get to choose one of them when you design an experiment. These designs are independent groups, which is also called between groups, repeated measures, which is also called within groups, and then matched pairs designs. And when you design an experiment, you have to decide, do you want it to be independent groups, repeated measures, or matched pairs, but not multiple of those things. You only get to choose one. So I want you to think about your own research projects and the different types of experiments that could work best. Even if you're not doing an experiment, just think about which of these designs would fit or could fit to help you test your hypotheses. And when you choose the designs, keep in mind that you get to choose one thing from category 2 and one design from category 3. And that will kind of help you create experiments in the future as well. Now let's talk about basic experiments and what these are. When we hear basic experiments, and discuss this in chapters 8 and 9, when we talk about basic experiments, these basic experiments are a little bit different from when we learned about basic research in chapter 1. In chapter 1, we learned about basic and applied research, and the focus of that distinction between basic research and applied research was on the purpose or the underlying motivation for conducting a study. If you recall, basic research is research that's often rooted in theory, conducted in laboratories, and it's research for the sake of knowledge. A researcher might be curious about a topic, so they do a study on it, but it doesn't actually have to impact people or try to address a practical problem. That's when applied research comes in. Applied research is, well, research for the sake of application. Researchers tend to look at a problem or an issue that affects people in the real world, and then they do research on that issue to try to find a solution to that problem or address the issue in some way. Basically, applied research is research for the sake of application to actually address a real world issue. And basic research tends to be research that's more just for the sake of knowledge and curiosity. Again, though, that was the distinction that was made in Chapter 1. The interesting thing about that is that both basic research and applied research can take many forms. We can have experimental and non-experimental designs that are both basic and applied in nature. In other words, you could do a basic study or a basic research study that's a non-experimental study. It's not an experiment. You could do an applied study that is an experiment. Those things are not mutually exclusive. All of this is to explain that here in Chapter 8, when we're talking about basic experiments, it doesn't mean the same thing as basic research. A basic experiment is just the most simple type of experimental design that we could run. It's a design that has one independent variable and one dependent variable, and that's it. That's why it's called a basic experiment, because it's as simple as it gets. Now, again, though, the underlying motivation or purpose for a basic experiment could be rooted in basic research or applied research. Think of that motivation for research, basic and applied, that's different from a basic experiment. And again, just to kind of sum, basic experiments are called basic experiments because they're the most simple type of experiment you could have. There's just one independent variable and one dependent variable. Now let's go over some of the basics here and kind of build from where we've been talking about in the class previously. Keep in mind that in a basic experiment, we have two variables, and a variable is any event, behavior, situation, or characteristic that varies or changes. So here we have two things that are capable of changing, and let's talk about the independent variable first. Researchers always do what with an independent variable? Do they measure it or do they manipulate it? They manipulate it. And so an independent variable is always manipulated. And the thought is that if we manipulate that IV, we will then observe changes in the DV. And when we manipulate an independent variable, we get to control how it changes, which is really cool as researchers. When we control how it changes, we often decide how many levels or points of change do we want it to have. The most simple type of basic experiment has an independent variable with just two levels because there's a starting point and then one point of change, and that's it. And so an example of this would be if we're interested in looking at the relationship between, let's say, drinking coffee and happiness. We could have two levels of coffee consumption. Level 1 would be drinking 0 cups of coffee. Level 2 would be drinking 2 cups of coffee. And then we could have participants in each group drinking 0 or 2 cups of coffee and measure them on happiness afterwards. This would be a very simple type of experiment where we have one IV, coffee consumption, and one DV, happiness. And the independent variable, coffee consumption, just has two levels, 0 cups and 2 cups. Now keep in mind that technically basic experiments can get a little bit more complicated as well. For instance, you could have an independent variable that has 3 levels or 4. Maybe you could take coffee consumption and you could have 4 different groups. Group 1 drinks 0 cups, group 2 drinks 1 cup, group 3 drinks 2 cups, and then group 4 drinks 3 cups. Does that make sense? You basically have 0, 1, 2, 3, or 4 different groups to that design. Now, that's still called a basic experiment because you still only have one independent variable, coffee consumption. It's just now we've taken coffee consumption and we've given it 4 different levels instead of 2. We've taken a basic experiment and we've made it a little bit more complicated. But again, at the end of the day, it's still what we would call a basic experiment because there's one IV and one DV, and that's it. So basic experiments always only have two variables, one independent, one dependent variable. And they also always have the three key features of an experiment that all experiments must have. What are those three key features? Hopefully we know, but to kind of give everyone a refresher, they are manipulation of the IV, random assignment, and experimental control. Again, all experiments must have random assignment, manipulation of the IV, and experimental control. Now, what we're essentially trying to do here with an experiment is to help eliminate the effect of confounding variables. Chapter 8 mentions confounding variables, which is actually something that we've talked about and given a different name for. A confounding variable, though, is a variable that changes or varies along with the independent variable. And that makes it very challenging or even impossible to determine which variable affects the DV. In other words, is the IV affecting the dependent variable, or is a confounding variable having an effect? We don't know, and that's the problem with the confounding variable. In past classes, we've talked about confounding variables and used the term third variables to describe them. We've also sometimes talked about eliminating alternative explanations when talking about the three things needed to establish cause. And those alternative explanations are also called confounding variables. With an experiment, we attempt to eliminate confounding variables by using random assignment and experimental control. And when we don't do those things, we see that internal validity could be threatened. Internal validity is the extent to which we can draw conclusions about cause and effect between our independent and dependent variables. And internal validity is always stronger in experimental designs because experimental designs have those three key things: manipulation of the IV, random assignment, and experimental control, which then help us establish the three things needed for cause. And those three things are temporal precedence, covariation of cause and effect, and elimination of alternative explanations. Again, experiments tend to be high in internal validity for that reason. But what we're trying to do with the three key features of an experiment are to reduce the extent to which confounding variables could have an impact. To show you what it looks like when confounding variables are present, let's take the classic example we've talked about. We know that ice cream sales are correlated with murder rates or crime rates, and there's a third variable that's having an impact there. What is it? The heat. We know that as temperature increases, ice cream sales increase, and as the temperature increases, crime rates increase. So two things like ice cream sales and crime rates happen to be correlated, but it doesn't mean that ice cream causes crime. We've done that example. That one's old news. Let's talk about a different one. Did you know that there's a correlation between the number of pirates that exist and global warming? Turns out that when there are more pirates in the world, global warming is actually better. In other words, global warming is less of a thing. So I want you to think about what that relationship would look like. Look at this graph here. Looking at that line, what type of relationship is shown? Hopefully we're all thinking like, oh, this looks like a positive relationship, right? But I want you to pause for a second, not literally pause the video, but pause for a second in your thinking. And I want you to look down at that x-axis. That's the horizontal axis that moves from left to right. Now on that x-axis, look at how the numbers are ordered. Starting here close to this corner where the y and the x-axis meet, we have the largest number here when it comes to looking at this variable number of pirates. And we see as we move further down this x-axis, what's happening to the number of pirates? They're decreasing. Here, as we are furthest away from that corner, we have the smallest number of pirates at 17. And the reason why it's so important to talk about the order or arrangement of the numbers on an axis is because basically here, we start with a high number, and as we move away from the corner, we decrease those numbers. It looks like we have a positive relationship, but in reality, we have a negative relationship. Let's talk about why. Here we can see that as the number of pirates increases, average global temperature decreases. So as one variable goes up, the other variable goes down. And you might be thinking, well, why couldn't we see that here? We actually can. It's just that because we're starting with a big number closer to that corner, this negative relationship looks like a positive one because the line now points upwards. It's still a negative relationship though. Look at what's happening here. As the number of pirates increases, average temperature decreases. So as one variable goes up, the other variable goes down, right? Another way of saying that is that as the number of pirates decreases, the global temperature increases. Again, we still have a negative relationship, but this highlights why it's so important to always start with the smallest number closest to that corner of the graph. And then as we move further away from the corner down the x-axis, those numbers should increase, not decrease. When we do that, we can correctly see the relationship as a negative linear relationship. Now looking at this though, I want you to think for a second about what we're actually talking about. It looks like as there are more pirates, the average global temperature is decreasing. So do you think that's a causal relationship? Do you think that everyone should just stop what we're doing, go out there, become pirates, and we'll help global warming? Probably not. But you know, I mean, if you want to take that up, okay. No. So I want you to think for a second, and this would be a good time to pause the video and think about what a confounding variable could be for this design. In other words, what's a variable that's maybe lurking in the background that could explain why global temperatures have increased as the number of pirates have decreased? So pause the video, take a second, think about a confounding variable that could happen here. So now hopefully we've thought for a second, and what do you think this could be? Why do you think that there's a correlation between our global temperature and the number of pirates? Maybe some of us thought of a variety of different things, like, well, the number of pirates that have existed across time has just declined as shipments and technology and other things have advanced and increased substantially. And with those things, like advances in technology and advances in shipping different goods through like planes and trucks and things like that, we've seen an increase in emissions as well. So maybe due to things like that, we see that global warming has started to increase, or our global temperature has started to increase, and also the number of pirates has just started to decrease. You might have thought of other things as well. There are many different confounding variables that could help us explain this relationship here. The key thing to remember though is just because two variables are correlated, it doesn't mean that one causes the other. In other words, we could all go out and be pirates, but it doesn't mean we'll save the earth, or it doesn't mean that the global temperature will start to decline. There are other things though that we could do to help with global warming. And again, this is just kind of an interesting correlation that we can see overall. Now, for the next 6 videos, I really want you to start thinking about your research projects. In each video that comes up, we're going to talk about a different type of experimental design. And I want you to try to take the variables that you're working with and the hypotheses that you're testing and try to fit those into each design that we discuss, figuring out what design would be best and what design might not be as advantageous. Keep in mind that there's no right or wrong answers here. If you can make a good case for why you should do a certain type of experimental study or even a non-experimental study, which is totally fine, then that's okay. A lot of research methods is thinking critically about the different types of designs that exist and figuring out which design works best for you and the research and the variables that you're working with. Again, there's no clear right or wrong answer here, but as we cover these 6 different designs, one of the best ways to help them really stick for the long run is by putting them into a study that you're already working with, your research projects. So what we're going to do is stop sharing here. And when we come back for video 2, we're going to talk about the first type of design, which is a post-test only. All right, I'll see you all then.